right, our advanced Desmos task number 22, we're factoring a quadratic expression. And in my experience as a teacher, factoring is something that usually gives students a bit of trouble, a little bit of challenge. So in Algebra 1 last year, factoring quadratics is among one of the tougher skills to learn. And it takes some students years to master it. You see it in Algebra 1, you see it again in my class in geometry, and you'll see it again from here on out. You see it in Algebra 2, you see it in pre-calc, you see it in calculus. And it takes some students some years to actually master this skill. You don't have that kind of time when you're actually taking a test like the SAT or the PSAT. So we're going to enable Desmos to figure out what the factors of this quadratic are supposed to be. And when I look at box number 29 there, you can see that it's surrounded in quotation marks. I just use that so I can format the text. I can go over here and I can try to delete these, maybe speed this up a little bit. So I delete out my little quotation marks, and then I have a quadratic expression. And the only reason why I don't see anything is because it's deselected over there in that box number 39. Strictly speaking, though, I shouldn't see a graph at all. What I should see is actually just a couple of dots well, no, actually nothing. I shouldn't see any dots whatsoever because it's not an equation. It's not like I'm putting x values in here and seeing what they pair up to with y values. I'm just have an expression. However, this is what Desmos is going to do for you. If I turn this thing on, it does turn this into a quadratic here because it assumes that you mean y equals. So it goes and pairs up all your x values with some y values. And you can see this play out if I just put my cursor to the front of this quadratic expression here. And if I type in a y equals, and you can see that the graph didn't change at all. Because that's what Desmos is assuming. And I'm going to suggest that you try to get into the habit of, hey, this is just 2 extra keystrokes here. Put a y equals because it's often much more handy if you do. Okay, so believe it or not, the factors that we're looking for are on the screen currently. And the reason why they are is because whenever I'm looking at a quadratic, if you think about the x-intercepts of a quadratic, where it touches the x-axis, these things have a couple of different names. X-intercepts are called the zeros, they're called the solutions, they're called the roots, and they come from the factors of that quadratic. So actually, let me pull these guys in. So I'm going to pull them into the expression list, and of course, it's going to put this in a weird location. Let me put them where I want them to go, and let me get this guy over here and over here. Okay, so generally speaking, this is what the equation is going to factor out as. And it is a type of form of, that's the wrong thing here, it is a type of form of quadratics that's called intercept form. And intercept form for a quadratic looks like this. Y is equal to A, parentheses, x minus p, where p is an x-intercept, and x minus q, where q is the other x-intercept. And if you were to expand all of this out and combine all your like terms, you would ultimately get something like this: ax squared plus a bx plus a c. The only numbers that actually exactly line up are these two a's, the two leading coefficients. Those are the only things that would be exactly the same. The b would come from a combination of, like I said, combining some like terms here, and the c would come from not only combining some like terms, but you're also distributing this a through there as well. Anyway, so if I go back over here, I pretty much have what my factors are supposed to be, because like I said, these are just the x-intercepts within this factored form of my quadratic equation. So let me show you that whenever I type this thing in. Now the thing is, whenever I type this thing in, I'll type it in as y equals, and then just put my numbers, the 7 and the negative 1.5, in my set of parentheses with my x. So open up my parentheses, x minus 7, and you can see it hits exactly at that x-intercept, but it's a line right now because I have this thing formatted as just a linear. But as soon as I arrow out of this thing and open up a new set of parentheses, I'm going to do x. it would be minus a negative 1.5, but minus a negative just cancels out and makes it a plus. So plus 1.5, and then you can see that it hits the other one. But my two parabolas don't exactly line up, and the reason why they don't is because my leading coefficient is different. Up here in box number 39 has a leading coefficient of 2, but if I were to FOIL out box number 42, x times x is x squared, and it's missing its 2. So we can fix this like super quick. I'll just put my cursor right in front here, put a little 2, and now you can see that these graphs are identical to each other, right? You can turn these things on and off, and you can verify that they are exactly the same. So essentially, I have this thing in factored form. Now, there is a little something that you may have to do to this thing. For example, if it's a multiple choice kind of question and it's in factor form, you probably won't see a decimal number inside of the parentheses. There's no way that if you're factoring this by hand, that's the kind of thing that you would get. So let me show you algebraically what you can do to kind of fix this in order to get it to match up to one of your answer choices. Okay, so if I write exactly what I had on my Desmos sketch, which is 2 parentheses x minus 7, and then x plus 1.5 here. Instead of like taking this 2 and giving it to this first set of parentheses, I'm actually going to distribute this 2 to the second set. And here's how I know that that's going to be the case. First of all, I usually don't have a decimal whenever I factor. Usually these things are integers inside of the parentheses. Also, if I distribute this 7 or this 2 through this x minus 7, it's going to put a common factor of 2 in both of these places here. And usually that doesn't happen in factors either, because if a set of parentheses has a common factor, you pull it out, you factor it out, okay? But watch what happens when I just take this 2 and I distribute it to just the second set of parentheses here. So I'm going to distribute it here. Now, just so we know, just so we're clear, this 2 on the outside does not distribute to both set of parentheses. If you try to distribute to both set of parentheses, then you didn't distribute 2. Overall, you distributed a 4. You multiplied this thing by 2, and then you multiplied this thing by 2, and you would get a total of a leading coefficient of 4, which doesn't match our original equation. Okay, so let me distribute to that second set of parentheses and then simplify as I go. So I have y is equal to, bring down this one, x minus 7. And now this 2 times the x makes this 2x, and 2 times 1.5 is 3. Now watch this. If I go back over here to Desmos really quickly, I can type this in as another equation. You're going to see that it's exactly the same, and it should give me a different color here. So y is equal to, parentheses, x plus 7, and then another set of parentheses, 2x, and then plus 3. Oh, that's why. That's why. It's like, wait, this is like totally backwards. It's because this one is supposed to be minus. So minus, where's my minus key? It's right there. And I don't like this one being black because that's the same as the other one. So let's say we do orange there. And now you can see just like the 42, 43, all of these things are exactly the same. So we have successfully factored our quadratic. And yes, absolutely, there's a way to do that by hand using the AC method and things like that. But in the heat of the moment, on a time test, this Desmos could really speed up and automate some of those processes for you.